Hey guys, welcome to Module 20. There are 4 modules after this left over in the semester, so can you believe it? We're almost there. I'm in the process right now of compiling your marks for the end of the semester, looking at all of the quizzes that you've handed in, if you've submitted questions for any of the assignments. I'm going to look over that stuff and just get a good picture of how things have gone for you for the remainder of the semester. So I'm going to compile that data and then have a look at it and see if sort of like the average data is indicating that your mark has increased, and if it has increased, by how much. I think some people can probably hope to expect a modest increase to their mark. I don't think anybody from what I've seen is going to see like a huge increase to their mark. Some people may see no change depending on how things went in distance education, but just for you to be aware, none of you will see a decrease. There are a couple students that still have to complete some assignments from the semester. So I'll be emailing you and letting you know that you still owe me some stuff from before March break, although that list is relatively small. So if you know you're that person, maybe get ahead of it and send me what you need to send me. But either way, here we are in the 3 weeks, I guess, 2 and a bit weeks to the end of the semester. We've made it through most of this. I know it's been a long road. So far in this unit, let me get right down to business here. So far in this unit, we've been looking at what's causing climate change, a little bit about what is currently happening with regards to climate change. You guys looked a little bit at your personal contribution to climate change in terms of like, so what do you do to create greenhouse gases in your everyday behaviors? Now, in this lesson, we're going to look at the future predicted impacts of climate change. So most of this stuff that we're going to talk about today is based on an amalgamation of a huge body of research that was examined by the International Panel on Climate Change, which is a large group of scientists that are compiling climatology data from countries all around the world. And then the idea of this panel is that they're going to present the best data. They're always trying to present the best and most accurate data to depict our current knowledge and our best predictive knowledge about what could potentially happen with climate change. And we didn't do the chapter in the textbook on predictive models and how they work, but you can feel free to read it if you're interested. But they're pretty good. So far, a lot of the predictive models that we've used over the past 20 years have very accurately predicted the changes in climate over the past 20 years. And we have every reason to believe that we have fairly good predictive capacity into the future. So this lesson is going to be based on some of the predictions that are based on those computer modeling of future climate. And what the potential outcomes could be based on our current understanding of the impacts of climate on a whole bunch of different factors. And you'll see what I mean as we go along. So at the end of the lesson, hopefully, what you're going to take away is that you'll be able to pick out what are some future effects of climate change. There are a lot. I'm not going to cover every single potential one that the IPCC, the International Panel on Climate Change, discusses, because I mean there are thousands potentially, but I'm going to talk about some of the major impacts. So you should be able to describe some of them, and hopefully through looking at that stuff, you're going to understand some of the urgency to why we want to try and restrict global warming to the new value that people are talking about is 2 degrees Celsius from pre-industrial levels. So when we talk about pre-industrial levels, the Industrial Revolution, which began somewhere around 1850, that's where humans started burning a lot of fossil fuels for various reasons. We started producing greenhouse gases in large quantities at that point. And that's where we really started to see human-made anthropogenic climate change in the climate record. So there are fluctuations that happen to climate from time to time, and those are recurring throughout Earth's natural history. But right around the Industrial Revolution, when we started creating a lot of these greenhouse gases, that's when we started seeing a departure from those natural cycles and started to see a lot of anthropogenic climate change. So if you look at this graph right here, you will notice that in the early days of the Industrial Revolution, when we weren't really producing a lot of greenhouse gas, the climate, there was a general trend of increase here in the climate, but it was fairly modest, and perhaps it was undetectable at that point. But since then, you'll notice that the increase has been significant, and the increase is increasing. In other words, the slope of this line has been going up as we increase the amount of greenhouse gases that we're producing. In other words, there's a direct correlation here between the amount of atmospheric greenhouse gases and the average global temperature. The dotted line at the end here is predicted temperatures. When we talk about an increase of 1.5 degrees Celsius, so an increase of 1.5 degrees Celsius is what scientists and, I suppose, policymakers were hoping to limit the climate change to, that we would hopefully level things off by 1.5 degrees Celsius. Unfortunately, over the last 20, 30 years, instead of really doing anything about the problem of climate change, we've really done very little. So because of that, the actual chance of hitting the 1.5 degrees Celsius increase is very low. So I've included a link to a Vox article. It's a great article that talks about why the 1.5 degree limit is kind of untenable. It's basically not possible for us to do any longer because we waited too long. And so now, in order to actually achieve that 1.5 degree goal and reduce our amount of fossil fuel use, we would have to invest trillions. I think they mentioned in the article that it's more than what the U.S. would have invested per capita in World War II, but every country would have to do that, and it would have to be directed towards mitigating climate change. So I think it's fairly reasonable to assume that that is not going to happen. I don't think worldwide we're about to invest trillions in mitigating climate change, which is unfortunate. I mean, it would be great if we could do that, especially once you see some of the consequences of 1.5 degrees of warming. It will be significant. So 1.5 degrees of warming is going to occur. I think it's pretty safe to say that we're going to see that much global warming occurring. And there are some consequences to that, which we're going to talk about. A new sort of benchmark that is a possible restriction that we could attain is this idea of restricting things to 2 degrees Celsius. So what we're trying to do now is to limit the curve here. Now, when I say we are trying to do, there are people that feel that we could still attain the 1.5 degrees of total warming. But again, I'll let you decide. You read the Vox article and see if it's a realistic goal for the world. I think it's unlikely. But hitting the 2 degrees Celsius mark is probably a realistic goal for humanity. So I'm hoping that we'll hit it, because the real problem here is that if we don't hit it, we could potentially see an increase of up to 6 degrees Celsius. Now, a 6 degree increase would be catastrophic. So we would see, you'll see what happens at 1.5 and 2 degrees, a lot. And so at 6 degrees, if we don't do anything about this problem, we're going to see large-scale, global, severe impacts of climate change regarding all of the factors that we're going to discuss in a minute. And obviously, we're hoping to avoid that for economic reasons, for human health reasons, for ecological reasons. There's lots of reasons that you wouldn't want 6 degrees of warming. It's a very, very severe increase. Now, I should mention that this graph is predicting here 2 degrees of increase by 2063. That's 2 degrees of increase by 2063 if we do nothing. So hopefully we don't do nothing. So ideally, we will hit the 2 degrees of warming much later than 2063, somewhere around 2100. So that would be if we began in earnest mitigating the amount of greenhouse gases that we're producing right away, or we took large-scale action somewhere in the very near future. So I'm hoping that that's going to be the case. Certainly, I will be pushing for that, and I'm hoping once you see what the potential consequences are of climate change, that you will as well. You may have heard or participated in the climate walkouts that happened earlier. Was that in this school year, last school year, or this school year? And maybe if you participated, maybe you already know about some of this. And if you didn't participate, maybe you didn't understand why people did participate. But it is a very significant global issue, and not as much is being done as you might expect. Very little is being done. I shouldn't be glib about it, because it's actually really saddening to me. But anyway, so here, what we're going to talk about here are the predicted consequences here of 1.5 degrees of warming and 2 degrees of warming. So 1.5 was the original goal set by the Kyoto Protocol in the 90s. Wow, we didn't even come close. We really didn't. We didn't hit any of those benchmarks. So 1.5 degrees is probably unlikely. We're going to talk about what could potentially happen with 2 degrees of warming. And then you can at least consider what would happen if there's greater than 2 degrees of warming. And obviously, most of these things would be exacerbated. They would be much worse. Okay, so let's have a look at some of the potential consequences here. So first of all, it's important to note that when we see warming, the warming is not the same everywhere on Earth. So what ends up happening is that we see a concentration of warming towards the poles. And there are certain places on Earth that experience more warming than other places, just because of the way that heat is distributed in Earth's natural climate systems, like through wind and currents and all the other kinds of climate systems that distribute heat on Earth. There are some places that are going to be warmer than others. So you will notice that the severity of the warming and where it's localized is very significantly different if you look at only just a half a degree Celsius. The average temperature in the Arctic, for example, at night, and this is on the coldest days, where you would be potentially protecting sea ice, are much, much higher. They're potentially 2 or 3 or 4 degrees higher in a lot of places in the high Arctic on the coldest nights, which just means less opportunity for ice to stay ice. And previously we've discussed a little bit about this, but the ice in the Arctic is acting as a mirror. It's reflecting sunlight back up into space. And so if you remove some of that sea ice, you actually increase the rate of warming. So that's problematic. One of the other issues with this is obviously heat waves. The opportunity for there to be heat waves is much higher with 2 degrees Celsius of warming over 1.5. And we're probably going to see that. We're probably going to see a significant increase in the number of heat waves that happen and how long each heat wave is. So that's a problem. Because we're losing a lot of Earth's ice, we're going to lose a lot of glaciers. And I think this was mentioned probably in the other lesson where we talked about current problems. We already are seeing a lot of loss of glaciers. But if we do happen to lose a very significant portion of glaciers on Earth with 2 degrees of warming, that's going to mean that probably a third of Earth's population is not going to have their source for fresh water. That's 2.6 billion people having difficulty obtaining fresh water. Wow, that's a lot. Problems like that are massive because when fresh water is gone, it's absolutely essential for human life. You see desertification, you see people having to migrate in order to access fresh water, and that causes conflict. I like to use the conflict in Syria over the last few years as a example here of how a fairly small global conflict, it's localized just to the areas around Syria at least, something that probably has had very little effect on your own life, or likely has had very little effect on your own life, has caused so much strife with people having to relocate, having just when we've seen refugee relocations due to the conflict. It's been a huge political issue in Europe. Anyway, and that's fairly small scale. We're only talking about tens of millions of people in that case. With this, we're talking about billions of people relocating, a very, very large amount of people relocating, and not necessarily just to the fact that they can't find fresh water. We're going to talk about some other reasons why people may relocate later. But anyway, that's going to be very significant. So people are going to lose access to fresh water. We're going to see more precipitation. So that sounds a little bit unusual on its surface because oftentimes when we talk about global warming, we talk about drought. But it's also true that when the earth is hotter, more water evaporates from the ocean and therefore more rain falls. But the problem with the extra rainfall that you get with increased temperatures is that more water falls in extreme weather events. In other words, the rain that you get isn't pitter-patter rain, it's extreme flooding rain, where you get a super hard downpour for a couple hours. So the problem with that type of rainfall is that it doesn't have time to absorb into groundwater. So it just runs across the land, it causes flooding and damage to homes and infrastructure, and then it runs into waterways and into the ocean, and it doesn't replenish groundwater for people to drink. So that's problematic, and also the damage that it causes is problematic. So we're probably going to look at, we're going to see more problems with groundwater depletion. Even around here, if you've tracked the number of severe weather events that we've had in Toronto, for example, we've had more flooding in the last 10 years than over the past 50 or 60 years in Toronto. So I should have put some graphs in here too to back this stuff up. But anyway, you've probably seen it on the news that we've had a lot of flooding events recently, and then they are becoming more frequent. Extinction. So there are a lot of ecological issues associated with climate change. A lot of estimates suggest that we could potentially, and this is with doing nothing, by the way, with us completely ignoring the problem and not attempting to mitigate it, we could potentially see 30% of species go extinct by 2050. And you guys did ecology in grade 9. Hopefully you're aware of this idea that ecosystems are fragile and that they are a web of energy interchange, and every organism has a niche in that web. And when you start removing organisms from the web, you start unraveling the web, and you start removing niches, important ecological roles that animals and plants and fungus play. And when you do that, then you run the risk of potentially causing a ecosystem collapse, where you've removed keystone species, and then no species are able to survive in your ecosystem any longer. Obviously, the more species that go extinct, the higher the risk there the higher the risk there is of that occurring. So, some of the computer modeling has suggested that at the 1.5 degrees Celsius mark, which is possibly not attainable any longer, 6% of insects, 8% of plants, and 4% of vertebrates like us are going to see their geographic range reduced by more than half. That's crazy. 4% of vertebrates are going to lose half of their range. Wow, no wonder there's a potential for 30% extinction. If you look at the 2 degrees Celsius warming, and by the way, this is just due to climate change. There are other factors that are potentially concerning for species. There's habitat loss, pollution. There's lots of other factors that are causing extinction as well, but we're just talking about the climate change impact here on extinction, which is very significant. If you look at this table right here, or at this graph rather, and you look at the extinction rates over time, you'll notice that right around the Industrial Revolution, we've seen basically a exponential increase in the number of extinctions, and that's due to all the factors that I just mentioned: habitat loss. But climate change is playing a role in that as well, and it is certainly exacerbating the extinction problem that is currently happening. So, anyway, at 2 degrees Celsius, which is very likely at this point, Instead of just seeing 6% of insects losing half their range, now we're talking about 18% of insects losing half their range, and 16% of plants, and 8% of vertebrates instead of 4% losing half their range. So that's a big difference, and that's only half a degree Celsius. So keep that in mind. And also keep in mind that if we don't limit it to 2 degrees Celsius through whatever, by not taking appropriate action to mitigate our production of greenhouse gases, these numbers could be much higher. They could be devastatingly higher. So, and that would be very problematic. Anyway, so extinctions are a real concern. This is probably the thing that you're the most aware of. We're seeing more extreme weather events. So if you look at extreme events like fires, wildfires, flooding, tropical storms, all of those kinds of things, you'll notice that over time, those things are increasing. At the bottom here, they added in geophysical events as sort of like a control group. Because if you look at those at the bottom, that's in red down here, you'll notice that number actually hasn't changed much over time. Like the number of earthquakes and tsunamis and volcanoes, that's relatively constant over time. But virtually all of these other types of extreme weather events are increasing year on year. And much of this is attributed to climate change. So, why is that problematic? Well, when we have those types of severe weather events, we have loss of crops. People get displaced. Their houses are destroyed. Sometimes they're killed. We see destruction of infrastructure, roads, bridges, everything gets destroyed in these severe weather events or forest fires. And those things are extremely, extremely expensive. Insurance companies are going out of business because of the amount of additional strain caused by these adverse weather events. Governments are having difficulty providing aid to people. And certainly if you live in a developing country, sometimes there is no aid. There is no way to help people. There is no money available to help people that are experiencing problems because of these weather-related events. So these are very problematic, and they are increasing because of climate change. We talked previously about the fact that the sea levels have already risen, so we've seen an increase in sea level, but there's also obviously the prospective future increases in sea level. And this little infographic here shows a 2-degree warming and a 4-degree warming, and looks at the difference in the population that would be potentially affected through displacement, or potentially the population that would have to build seawalls or something in order to prevent flooding due to sea level rise. And you'll notice it's all coastal countries. We're talking about ocean level rise here. So with a 2-degree Celsius warming, which we're probably going to see and hopefully limit, 13% of New York is potentially going to be, in terms of population, be underwater. So that they will have to build some type of seawall system in the future in order to mitigate, or in order to adapt to climate change. But if we don't take the appropriate action and we see a 4-degree rise, that number changes to 23% of New York's population. That's very significant. We're talking about millions of people in that case. If we look at countries with higher population densities like Japan, Tokyo specifically could have a 16% population affected by rising sea levels, or if there's a 4-degree warming, 30% of their population. And those are two developed countries, Japan and the United States. They're probably going to build and adapt through infrastructure. They're going to build seawalls. They will adjust their infrastructure for prevention of seawater infiltration. But a lot of these other cities that are on here are in developing countries that probably don't have the economic ability to adapt. And so people, for example, Hanoi is a great example. 30% of their population potentially could be displaced in the case of a 2-degree warming, and 60% of their population in the case of a 4-degree warming. That's a huge number of people. It's millions of people that would be potentially displaced, and those people have to go somewhere. That is inevitably a source of conflict. Anyway, I'll let you take a look at this infographic here at your leisure if you want to look at some of the other locations. But worldwide, this is a very significant issue. We build our large cities close to water because of the transportation that it allows. So a lot of cities are potentially in a lot of trouble here. Okay, in summary, well, I've talked about a whole bunch of different things here. Looking at the difference here between 1.5 and 2 degrees of warming, keeping in mind that we probably have passed our ability to restrict things to 1.5 degrees of warming. I suppose it is possible, but it doesn't look likely. But that still leaves us with a new goal that we should really, really be fighting for. And certainly without the population forcing this agenda politically, I don't think we're going to see a lot of action on this. So we have to push for this. That's our job, our generation's job to do that. And hopefully, you will choose how you want to participate. But it is, hopefully you can see that it is something that will be important. Okay, so we're talking about things like increasing the number of months where you could potentially experience heat waves, okay? An additional month of the year where we could be seeing heat waves. A decrease in fresh water availability worldwide between 9 and 17%. Again, that's if we restrict it to 2 degrees of warming, 17%. That's such a huge loss of freshwater resources. An increase in heavy rainfall, again, in the type of rainfall that doesn't replenish groundwater and causes flooding, between 5 and 7% increase in heavy rainfall. Huge decreases in crop yields, and that's a product of having less fresh water available for irrigation, and also just simply due to additional heat. So you'll notice that for some of these crops, this is interesting, there is a decrease because a lot of places where they currently grow wheat may become desert. Corn, which is quite water intensive, would see a decrease in their production, but there are some crops that would potentially see an increase in the production because more land would potentially become available for farming for some crops potentially. Now, I don't think that it comes out even. We're certainly going to see the overall picture here is that we're going to see a decrease in crop yield, but there, as part of our adaptation to 1.5 and 2 degrees of warming, which we have to consider. We have to adapt to the changes that are going to occur. We may have to take advantage of the fact that some crops are going to be more easily grown in the future than they are now. So we may have to see a shift in the type of farming that we do. We're looking at a sea level rise. It's going to happen. For sure, we're going to see at least 40 centimeters of increase in sea level, but very likely 50 centimeters. And potentially more. So there's lots of land ice that wouldn't be melted at 2 degrees C, and we don't want to see all of it. And then the last part here that's mentioned, I didn't actually talk about this, I forgot to add this to the note, but because the oceans are becoming warmer as well, the pH, how acidic the oceans are, is going up. The oceans are becoming more acidic as they get warmer because they're absorbing more carbon dioxide, which becomes carbonic acid in water, and that causes reefs to die. Potentially 90% of reefs could be at risk with a 1.5 degree Celsius warming, and 98% of reefs if there's a 2 degrees Celsius warming, which is probably going to happen. So we're going to have to develop some type of adaptational strategy to protect reefs. Reefs are where young fish are raised, and those fish feed a huge proportion of the world that are growing up in the reefs. So we are going to have to figure out some type of adaptation, and then hopefully also consider mitigating climate change so that we don't make that problem even worse. Okay. The last thing I want to mention here is this idea of a positive feedback loop. So as we see warming occurring, and I mentioned this right at the outset at the beginning of the lesson, some things that occur are actually going to cause more warming when they occur by their nature. For example, if you lose sea ice reflects sunlight. So if you lose sea ice because it melts, the Earth absorbs more light energy, which it converts into heat. So the Earth gets hotter, which melts more ice, which makes the Earth hotter, which melts more ice, and that it's a loop. Okay, so that type of loop where a product of a reaction leads to an increase in that same reaction, and then it goes around in a loop, is called a positive feedback loop. So one of the reasons why it's so essential to restrict warming to these levels, to 1.5 or 2 degrees Celsius, is that we're trying to prevent really serious activation of positive feedback loops. So that melting sea ice that I mentioned is one of the positive feedback loops that we're trying to prevent. Because once we see very significant sea ice decrease, then that is going to increase the warming so much that it becomes difficult to stop additional warming. It's also true that permafrost, which is the frozen ground along much of the north of Canada and Russia, so that frozen ground has methane stored in it from rotting plant matter that was around 65 million years ago, and has been frozen in ice for a long time. So if you melt the permafrost, because the temperature increases, then you get a release of methane and CO2, which causes more warming, which melts permafrost, which releases CO2 and methane, which causes more warming. So then again, it causes a positive feedback loop. So we're trying to prevent the activation of these positive feedback loops. Initially, a lot of the discussion was around limiting things to 1.5 degrees Celsius, because hopefully that wouldn't activate these positive feedback loops. Now I think our best hope probably is to limit things to 2 degrees Celsius and hope that we aren't going to potentially activate a lot of those positive feedback loops. So it's not a great situation. I wish I had better news for you guys to say that we did a lot about this in the last 20 years or 30 years, really. We knew about this, but we just haven't. So I think the reason we make so much effort to educate you on this, certainly here in Ontario, is so that we do something about it, so that we can develop the pressure that's needed to apply to actually do something about this. And we're going to talk about some of those mitigation strategies in future lessons. That's where we're going next. We did talk a little bit about what you can do, but we're also going to talk a little bit about what can be done on a large scale in the future, on the scale of countries, with regards to tackling this problem. And that is something that is quite a bit more difficult. So anyway, that's the basics. So, and hopefully this isn't been hugely depressing for you. I know it's not a super fun topic, but it's important for you to know, like, this is on the way, guys. And so we have to do something about this. I think one of the big problems why there's so much inaction is that just people don't want to admit that this is happening, and that we know a lot about the potential future impacts of this as well. Our computer models are very good. So far, they've been highly accurate in predicting a lot of this stuff. So we have no reason not to trust that this stuff is going to happen in the future. Anyway, I don't want to bum you out here, because we are going to, in the future, talk about positive steps to mitigate. And I think that if you read that Vox article, I highly recommend it. It does talk a little bit about why you shouldn't be totally bummed and why we still can absolutely do something about climate change. So don't get totally bummed about this. There is a great opportunity here for us to do something about climate change. So, okay. Anyway, when you're done, you can give the quiz a chance at the end of the lesson. And this one did drop a little bit late. If you want to just finish this stuff up by the end of Monday, that's fine. You can take till the end of Monday to write your quiz too, if you'd like. Or, I mean, obviously it can take longer if you need it, but it's recommended just to help keep you on track. And I will see you guys next. I'll see you on Friday for the check-in, and I'll see you on Monday for our next lesson. All right, have a good one. See ya.